Hello viewers, welcome back to the Multimagic channel. Hope everyone are having a great time with the videos in our channel. So last week we have discussed about a particular topic called reverse video. So how do you reverse video? You store all the video frames in a buffer, and once the entire file is read, you need to read the video frames from the back, and then you need to tweak the PTS and DTS of the particular video frame, and then later you encode that, and then you get that reverse. So but today we will be discussing how to reverse video along with the audio, which is quite important. Okay, so on that note, let's start today's video. So today we will be discussing, so last week we discussed reverse video and no audio, in the sense it's already done and the video is released, and we will also be discussing about reverse video and copy audio as it is, and reverse video and audio, and reverse video and copy video as it is. First we will start with reverse video and audio. How reverse video and audio, this is of course that is our main intention. As we developed, we got some ideas like okay, so once we understood the basic tweaking behind how to reverse video and audio, we thought, why can't we play with different use cases? So in that process we thought, okay, let's reverse only video and keep audio as it is. Let's see how it goes. So instead of we just store the video frames, and instead of completely neglecting the audio frames, we just reading the audio frames as it is and just encoding. And coming to reverse audio and keep a video as it is, it's the same thing. You just play with the video frames and you just keep the audio frames as it is and encode. So let's see. I hope this will be a fun video, and then let's start on this. So before going to the coding, so let's see what is actually, let's quickly rethink what is video, reverse video. So here reverse video is pretty simple. So you have a MP4 file, and you are reading that from the MP4 file using the AV read frame of FFmpeg API, and then you just send packet and receive frames until the end of the file. So now once you receive each frame, so this frame is stored into a buffer, and until the end of file is reached, the buffer is full now. All the video frames which are part of this MP4 file are stored in the buffer. Audio frames we are still not storing in the buffer. I am just going to the video case now, and of course once then we start reading this frame and assign this frame PTS DTS of first, and then the last button, and so on. You read from the back, and then you tweak the PTS and DTS of the particular video frame, and then you just encode that video frame, and then once you encode, the data is compressed now, and you write the compressed data, or the encoded data is sent to the AV write. So that's how you get the reverse video. Okay, so now reverse audio is bit interesting. Actually we do faced couple of challenges while doing the reverse audio. So let me tell. First actually I just followed the way video is done, in the sense like, okay, there are frames, I just keep the entire frames into a buffer and read the frame from the end. So that's the typical reverse process. So now the same thing I did for audio. So while reading the file, I have I will be receiving audio frame and video frame. So once I received the audio frame, I stored all the audio frames into the buffer, and then I just previously this block is not there. So imagine I'm just reading from the back, and then I'm adjusting the PTS and DTS of this audio frame, and then encoding and then writing. So I did until the end of the loop. So what happened is, here is actually the reverse audio is not working. There's a lot of noises, and there is a lot of some it's not pleasant, even though the reverse itself is not pleasant, and the output I got is not even very pleasant. It's noisy and a lot of background noises there. So I don't know what is happening. So let's see. Then I used Audacity actually, and then with the help of Audacity I collected the raw data at each stage, and then I figured out that, okay, I missed a simple thing here. It looks simple after we find out, but yeah, what happened is, in each video audio frame there are samples. Audio frame is accumulated with 1024 samples. Just for example I'm telling, it can be 512, it can be 2048, or some samples, audio samples. So we need to reverse the each sample in that audio frame. You just not start reading from the back of the audio frame and writing it to encoding block. You need to first read this block. So that's what I mentioned here. So first you need to read the audio frames from the end of the buffer, and then that particular audio frame has samples 1024, and then you reverse the audio samples inside each frame, like okay, this goes here 1023, like that. So now this is my new frame or the reversed frame of audio. So from the back you need to read from the back of the audio frame, and within that frame you need to reverse the samples again. So two reverse we need to do. Two reverse in the sense you need to read from the back of the buffer, at the same time you need to reverse the samples inside. In case of video, you just need to read it from the back because there are no samples here. You just need to write that particular video frame into the encoder. Here you need to read and then actually write this into the encoder frame. I mean to the encoder. So now what happens is like so the file will be reading, and the video frames data goes to the video frame buffer, and the audio frames data goes to the audio frame buffer. So the decoding is done. So before encoding, what you do is, so while encoding, okay, we start reading from that buffer from the back, and then we tweak the PTS and DTS of the video frame, and then we send to encoder. So when it comes to audio, you read from the back, and you reverse the samples inside each frame, you tweak the PTS, DTS, and then encoding. So like this, the parallel processing will be going on for audio and video. So what I meant is like this particular process and this process will go hand in hand, like so video and audio both process will be taken care. So now let's see the code part, how to achieve this, and then we'll see all the cases. So let's start with that process frames block. Okay, yeah, so this is my process frames block where I read all the from the file I read all the frames. So I will be getting video frames, I will be getting audio frames continuously. If I get video frame, I just do transcode. I mean video frame means here it is actually storing all the usually you transcode, but in the case of reverse transcode means you just simply store all the frames inside the buffer here. So this store AV video frame goes here, and then yeah, you know how to copy a AV frame. So there will be input frame. Since this is a type pointer, you cannot copy pointers, you need to do a deep copy. So you need to copy all the data inside this frame. So for that I allocated a new frame, and then I assign the properties, and then I assign the memory here, and then I copied all the properties of the input frame, and then I copied all the data of the input frame into this temporary frame, and I'm finally adjusting the PTS and DTS. Here I am assigning the input frame PTS. It is just caution step actually, just to ensure since this is the most important parameters in this feature, we need to ensure during copying if some other junk value is written, just in case, just a cautious step. So finally we are storing this. So now the audio frames are stored. Now coming back to the video frames, so now go to the transcode audio code. So same thing here, transcode audio, you get the raw frames here, and once these raw frames I'm writing and I'm storing all the audio frames. So for audio is also same. Since it's a pointer type, you need a deep copy. I'm allocating a new AV frame. So for video there are different properties. For audio, these are the properties that need to be taken care, and like format, channel layout, and number of channels, whether stereo, mono, and sample rate. Usually it is 4100 kilohertz, and number of samples per frame 1024, or frame size it is called. So all those basic details I am telling how to my frame should be. And finally you allocate buffer to your frame, and then you copy all the properties of the audio frame to the temporary frame, and then you copy the data and then this is a cautious step, just ensure PTS and DTS is what we want, and then you just push these things into the audio frame buffer. So now we have two buffers as discussed in the diagram, like we have video frame as well as we have the audio frame now. So now let's look into this. So after storing, and then okay, now the decoding part is done. So now we need to encode. So during encode I am mentioning, okay, if reverse audio flag is on, of course in my command line I am telling reverse the audio. If reverse audio is not there, this particular block will not trigger, and instead of storing the buffers into the frame, it will just encode the audio as it is. So you can see that here in this condition, that's what if the reverse video flag is off, I don't want to reverse the video, I want to keep the video as it is, yes, to just simply go and encode instead of storing into the buffer straight away. So that's the one of the use case we discussed. So let's see regarding the audio thing. So now you go to the transcode audio. Okay, so you go to the transcode audio here, and then okay, so same thing, I got the raw, I stored the frames into the buffer. So now during encoding part, yep, so this is all reverse audio. So okay, so now I am reading from the, as I mentioned, I am reading from the last of the buffer. So my buffer size is this, and I am reading from the buffer from the last. Again, since it is of type pointer, you cannot copy the pointer, you need the entire data of that particular AV frame to be copied. Yes, same thing I am following. I am just allocating a new frame, and I am just assigning the properties from the original frame. Okay, this is how my reverse frame should behave. These are the configuration of that particular frame: sample rate, channel layout and format. And then I allocate memory for this. After allocating memory, I copy the entire properties of the original frame to this reverse frame, and I copy the entire data. So now this is the main difference. See, in video you have this AV frame copy underscore data. So here you will be not using that, you will be not copying the data. Here instead you manually iterate through the channel. So this is what my channel, so my frame. So that frame has 1024 samples, and it has that samples is combination of channel 1 and channel 2. So I go to the channel 1, channel 0 first. Okay, from source I extract. Okay, this is my source and this is my destination. Okay, this is the original frame and this is the reverse frame. So I am copying all the frames of the source in the reverse direction to this. So that's why I copy. Okay, you iterate the number of samples, but you copy the destination plus j star bytes per sample and the 1024 samples bytes. So here you will calculate the number of bytes per sample. Here it is a floating, here it is a floating type format. So the number of bytes it is supported is 1024 bytes per sample. Let's keep a breakpoint and then see what it is happening here. So that's it. This is so, and then you copy. So you just simply copy the last frame data of audio in the reverse direction of the samples of both the channels. So this is what the block is doing. And then finally I'm just tweaking the PTS and DTS. Yes, it is the first frame PTS, I'm assigning it to the last frame, and the last frame DTS I'm assigning it to the first frame DTS, I'm assigning it to the last frame here, since we are reading it from the direction, backwards direction. And then finally we encode that reverse frame. So just to quickly think, so I am reading it from the buffer from the end, and then I am doing a deep copy of the last frame, and once the copying is done, I just instead of the copying means I'm just not copying, I'm just copying the properties. In this case of audio, when you want to copy the data, I don't want to copy the frame data as it is, because AV frame copy underscore data will copy the frame as it is, but I don't want that. I want to go inside that frame and copy the samples in the reverse direction. So that's why I have took 2 bytes per sample and channel, and then yes, original frame, extended data, and you take this to reverse frame, and then you copy all the data here, bytes per sample plus original frame samples minus 1. I'm copying from the end samples, so each sample I'm taking from the reverse direction in that particular frame, and I'm copying it. This is actually a very challenging here. If you see, you need to understand what are the channels, frames, data. So what is extended data, what is data, how to allocate memories, all those things. So even though the code of piece looks small, we felt really challenging at this particular phase. And now, yes, you tweak it and then you encode it, and then now the video and audio, both the video frames, audio frames are both reversed now and are encoded. That reversed frames are sent to the encoder and encoded it, and finally we write it to the file, and then we edit with the trailer. So now let's see what is happening if you actually look at the demo now. So now this is my application. So the properties what I have is, okay, so first start with, okay, let's start the fun part. So let's start with no audio, in the sense, okay, reverse the video and copy the audio as it is. Okay, so now let's start running this application. Okay, okay, it's going on. Okay, so the transcode of audio frames and video frames are going on. First it is storing all the frames into the buffer. Both, only here the video frames are stored into the buffer, audio frames are not stored into the buffer. The audio frames are just stored into the buffer, and then the reverse of the samples, everything is happening in the background. Okay, I mean, sorry, so this case is we are only reversing the video, we are not reversing the audio. So only the video frames are stored into the buffer and audio frames are encoded in the real time. Okay, so now let's see what will be that video. So okay, my downloads folder is here. So yeah, you can see that is the beginning of the music. The trailer is the beginning, that music, but the video is playing from reverse.
Is it better to be feared or respected? I say, is it too much to ask for both?
Yeah, so the video is playing in reverse and the audio is playing in the forward direction. Yeah, so this is just the fun part. So just to ensure, like, just to understand from the concept point of view how the reverse works. Of course, this is not a real use case. Generally nobody wants to reverse only video and then keep audio as it is, but just to see with the small tweaks how we can achieve some such different use cases. So now I just reverse video and audio. Okay, so let's start. Okay, so here again, now it will take a bit time, because you need to copy all the video frames and store it in the buffer, and you need to copy all the audio frames, store it into the buffer. Of course, yes, it's a time, not bit time consuming, but of course, as I mentioned, this is a kind of POC, and we'll definitely make it this particular application into much more productization, where multi-threading and different things comes into the picture, and we handle based on size based, time based, like a lot of things we can add. But at the core, the process will be same. It's like you need to store it into the buffer, and then after that you need to be reverse both. Some audio frames are copied, video frames are copied. Yes, so now let's look into let's play the video. Okay, it's again in my download folder. I am playing here. Okay, yes, now both video and audio are reversed. So let's see how the impact will be. Yes, this is the reverse of video along with audio.
Ja, står det danser med. Push my one get not and see the clips it's true. No, I didn't think it's sure what on the chef still.
Okay, hope you enjoyed that.
Yeah, it's not window. Right, see no. Very good, as you're feeling like that. Oh, besides, somebody's busy. Yeah, it's sound. Absolutely. If you don't have this. Don't worry, Doug.
My dad must do you on.
Oh, thanks. That's the cost, but I don't know.
It sounds like some different language, but it's still the English. So that's the fun part. So this is one more use case we'll see where we can keep the video as it is. Okay, just reverse the audio. Okay, I'm disabling that reverse video part. Okay, now let's see what happens. Okay, so now again same, this time only the video frames will be encoded as soon as it read from the file, but the audio frames we keep as it is. So now the scenario we are running is, yes, keep the audio as it is. Keep the video as it is and just reverse the audio. Okay, let's see that. So now in this case, if you whatever stream you are reversing, we will store that into the buffer, and then of course, yes, we will be other thing will be encoding on the fly. Okay, so now let's see. So I'm playing from the file. Okay, yeah, so video is as it is. It's video is as it is, but audio is playing from the back. You can see the, yeah, so that audio is the beginning of the audio is as it is, it's playing, but video is, yeah, it's interesting, cool. The video is as it is, audio is coming from the playing from the back actually.
Yeah, sir.
Okay. Yeah, so of course, this is also not the real case. So nobody wants to just keep video as it is and just reverse the audio, or the vice versa. But I'm just showing how we can play. So if you want, if you encode what happens, if you just don't want encode immediately, you want to store and then reverse the properties and reverse the data and reverse the samples, everything. So if you can keep certain conditions, and then you can just play with the code and you can create different effects on the screen. So that's what actually I want to convey through this reverse video and audio together. Hope everyone enjoyed this video, and in the next video we'll be discussing about an interesting thing called merging two videos. So yes, that will be really interesting. We'll start with merge two videos which has same specs, like which has same resolution and same codec IDs or same sample. So let's see how that will be. That will be an interesting session, because it's not straightforward as you think. You need to again play around with a lot of properties and a lot of challenges we faced. So let's end this video here for now, and keep watching. Thank you.